RL circuit. Things to remember for inductors: if the I constants or DC, V across ideal L is equal to 0 and then L is short circuits. I cannot change instantaneously in an inductor, that is, the current cannot change by a finite amount in 0 time. For example, when someone opens the switch on the inductive circuits in an actual system, the current initially continues to flow in the air across the switch. This is the example of the R circuit when T is more than 0. You can see that there is a source that exists in the circuit. As compared to the source free, you can see that in that circuit, there is no source. In this circuit, it consists of either voltage source with the current source or voltage source or current source only. In these RL circuits, you have to do the KVL equations in order to find the expressions of the IT. So this is the example. It considers that the switch is closed and then T is more than 0. By doing a KVL into the circuit, you can see that here is the summations of voltage is equal to 0, and then for the VT is equal to L Ti over dt. You can refer this expression through textbooks, and at the ends of the equation will be like this one, by reference to these figures only. At the ends, the general approach and then the expressions for the IT for the RL circuit is IT is equal to I infinity plus with the I naught minus with the I infinity times with exponent minus T over tau. This is the steady states, and then here is the transience value. For the I infinity, you can get the values of I when the T is equal to infinity, and for the I naught, you can get the values of the I naught when the times is equal to 0, and then tau, you can get the values of tau when the time is more than 0. So this is the first step, second step, and then this one is third step. Each of these steps consists of their own circuit. So there will be 3 circuits in order to find and determine the equations of IT. The time constants or tau is equal to the L over R Thevenin, which is the Thevenin resistance across the inductor terminal. You can determine this tau R Thevenin in step 2, which is when the step is more than 0. The steps of the RL circuit will be: first step will be when the T is equal to 0, and then here you will determine the I naught. There will be a circuit 1, and step number 2, when the T is more than 0, here you can get the tau value, which is the L over R Thevenin, and then the final step will be when the T is equal to infinity, and then you can determine the I infinity. During the first and third, the L will be, L is short circuits, and then the current will flow to that terminal, same as the step 3. There will be L is short circuits and I is flowing to that terminal, the I is I infinity. For example, we have inductors, and then during the first and third step, it will be short circuits, and then you can get the I infinity through the L terminal, same as the circuits number 1. In step 2, the L is exists in the circuits, and then you need to find the R Thevenin through across the L terminals of the circuit.